Welcome to my channel. This is Shakil Ahmed. In today's tutorial, we learn how to compute sample size when we wish to detect a significant difference between two proportions. Uh, this type of study is conducted in most of the research in health sciences and business sciences when we want to compare the two proportions of population, or there are two random samples taken from a population randomly, and we wish to estimate the mm, proportion difference in proportion in that in the two groups. For example, uh, we wish to estimate the number of smoker or percentage of smokers among male and female. Then P1 will be the proportion of smokers in male, and P2 will be the proportion of smokers in female. So we need to conduct a study to find the uh, difference in the two proportions. Basically, the difference matters here. If the difference is practically small and not significant, then we check statistically whether the difference is statistically significant or not. So for a larger difference, we need smaller sample to detect the difference, and for the smaller difference we need a larger sample size to detect the difference between two population proportions. So again we follow the same procedure as we uh, perform in performed in single proportion testing. We again go to the web page of EP tools, and from sample size calculation tab we select the option to detect a difference between two proportion. Then you will see this window or this tab in on your computer screen. So the first box is for proportion in population 1, which is the population proportion for first group, and the second is the population proportion for second group, and the ratio of sample size n2 divided by n1 is the ratio of number of people required in sample 1 and number of people required in sample 2, and the confidence level, which is usually taken at 95%, and the desired power of study. The power of study is also important. If we increase the power of study, it might require a larger number of sample size or number of units or individuals in the study. If we conduct a low power, then it will not detect or will not be able to detect a true difference in two population proportions. So for detecting a smaller difference in two proportions, we need to take a higher value of our power, and the higher value of power resultantly or consequently give the larger sample size required for our study. So uh, the inputs are described as true value for the two proportions P1 and P2. We need to estimate these two proportions from a pilot survey or from the previous researches related to the same topic, or related to the same setting or same population. The desired level of confidence and the desired power for detection of a significant difference, and the desired ratio of sample size between the two groups. This is the ratio of n2 divided by n1. If you take a value of 1, this means that you are taking equal number of sample sizes in both groups. By default calculation assume that a two tailed statistical test will be used. If you want to uh, conduct a one tail test, then you can click on one tail option. A one tail test is conducted to see uh, the one proportion in population one is higher than this other proportion in other group, or the proportion of smoker in male is higher than uh, we want to check the proportion of male is higher in male. So for such type of study we take or we conduct a one tail test. These tests are these type of statistical tests are known as non-inferiority trial in clinical trial language, or superiority trials. So we take an example. Suppose we want to compare two methods for treating cancer, and the experimental design might be as follows. Select a sample of patients and randomly assign half to one group and half to the other group. After 5 years, determine the proportion of surviving in each group and test whether the difference in the proportion is significantly different from zero. The power calculation assumed that the random samples are drawn from two separate populations, means population of those who were in control group and proportion of those who were in treated group, or the proportion of person who survive in first method of treating cancer and proportion of those who uh, survived in uh, second method for treating the cancer. Now we conduct the power calculations or sample size calculation in EP tool. So we again go to the Google Chrome and EP tool sample size. Then select the option of sample size calculation EP tools, and go to the option of two proportions. The proportion in population 1 is taken as zero point 0.3, and the proportion in population 2 is taken as zero point 0.2, and the ratio of sample sizes are taken as 1, and the two tail test is performing here, and then submit. These were our inputs we entered, and the outputs are 313 individuals from sample group 1 and 313 individuals from uh, group 2, with a total of 626 a total sample size. If we take we can also see sample size n1 for population 1 for various combination of proportions. These are different combinations of proportion 1 and proportion 2, and you can see a combination of proportions for selecting an appropriate sample size. If we change this ratio of sample sizes as 1.5, then we check the sample sizes into groups. Now we need to collect 258 individuals from sample 1 or group 1 and 387 individuals from group 2. So this is sample size calculation in studies where we are interested to detect the difference or the uh, discrepancy between the two proportions of population. of two different populations, or the two samples selected independently from a population. So keep watching and keep following my videos for more videos on sample size calculation. Thank you.